Okay, we're on the tangent function. So we've done sine, cosine. Now we're on to tangent. Okay, so recall. You guys remember that when we learned about the tangent function, it was tied to sine and cosine, correct? And then it is a ratio between sine and cosine. Or in terms of when we learned, it's also our, there's a lot of things at this point that we can say about tangent. No. So as we were saying, is that if we recall when we first learned about sine and cosine, going back to geometry, you learned that tangent was your opposite over your adjacent, correct? And that's where that came together. So from there in geometry, tangent doesn't stand on its own. Tangent depends on your sine and your cosine. Over the course of between geometry and what we've learned so far in this trig section, we've learned that tangent is the ratio between sine and cosine. Tangent is also the slope of the line that is connecting from the center to a point on the circle. That's your M. And then tangent is simply the relationship between your coordinates, your Y and your X, right? Because tangent creates a ratio, aka a fraction, that means that the denominator cannot equal what? 0. And if we go back to the first semester, we learned that when there's a 0 in the denominator, it creates a discontinuity. Okay? And that's what we're going to be talking about. All right. So as we did previously with sine, cosine, we're going to go around the unit circle and find the tangent of all of our key points. Okay. So when we're going around, we're paying attention to where our terminal side is ending. That terminal side, if you think of it as the slope, as a linear, there's a slope to it, right? And so when I'm here, going back to algebra 1, if I have a horizontal line, what is its slope? 0. Do you remember that? A horizontal line has a slope. When I have a line that is increasing, its slope is positive, right? Still increasing positive, but getting steeper. Still increasing positive, but getting even more steep. And then as I get closer and closer to pi over 2, what happens when you have a vertical line? It's undefined, right? And therefore, these are going to be our undefined moments. Does that make sense? So we have our horizontals. That's going to be when we are 0. When we are vertical, we're going to be undefined. Again, horizontal, vertical, undefined. That is how a tangent line is made up of. Okay. So from here, we know that every odd pi, we're going to be, I'm sorry, not every odd, every even pi. So pi, all the way around. We're going to be 0. Those are going to be our x-intercepts. Do we see that? And then every time we're at pi over 2 and it's 180, adding 180 to that, we're going to be undefined. And those undefined moments are going to create our asymptotes. Do y'all remember that? Asymptotes are the discontinuities that come into play. All right. So in this blank, we should write the slope of a vertical line is, what did we just say? Undefined. Okay. Do y'all remember slope man? Things that slopes can be? Did your algebra 1 teacher not teach slope man? All right, let's talk about slope man. Slope man, his eyes. He has an increasing eye. He has a decreasing eye. It's increasing, so it's a positive slope. It's decreasing, so it's a negative slope. He has a frown, and his frown can turn into a, that's his little tongue looking, and then his nose is undefined. And that is slope man. And he tells you all the things that your slope can be: positive, negative, undefined, 0. All right. So slope is undefined, and it is because the infinite every time here is going to keep going over and over because circles go around and around and around. So we're going to have infinite amount of undefined locations. Does that make sense? All right. So how does this help us create our chart, our table? Well, it helps us decide what pattern do we start at with our x-intercepts and our vertical asymptotes, where our x-intercepts and our vertical asymptote, and we'll continue that pattern all the way around. So our next one would be at 3 pi over 2. Keeps going. We're approaching. We're getting, now we're in our negative zone. Doom, 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 doom. Positive zone still. Doom, doom, doom. Doom, 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 doom. Hit it. And then this is where we end up at. Okay. So we end up creating this graph that has a bunch of asymptotes. Your asymptotes are at your pi over 2. So at your odd halves, not your even halves, at your odd halves is where we're going to end up having our asymptotes. So that's 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 11 pi over 2, and then they're opposites. Okay, so this means that we will see vertical asymptotes. So our blanks are vertical asymptotes when theta equals pi over 2 and 3 pi over 2 and every half turn of the circle from there on after. Make sense? Okay, so important features of the tangent function. When we're talking about the important features of the tangent function, blah, 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 I can't talk. We are looking at the same things. What is A? What is your B? What is your C? And what is your D doing? How are all these things come into play? So we have our vertical dilation of the graph. So your vertical dilation is still your A on the outside. We just don't call it amplitude because it's really not a distance because it's going forever up and forever down. It's just our vertical dilation, okay? Your period now, your period is defined by the absolute value of pi divided by b, okay? With sine and cosine, our period was defined by what? 2 pi over b. For tangent, it's defined by the absolute value of pi over b, okay? Our phase shift is still x's are liars. Even though this looks like this, I hate that they write it like this. You may see it like this on the test. I'm going to write it in its regular form because in this case, it wants you to think that C is negative, but it's not. So we're going to change this. Bothers me. Theta minus C, and then our C is whatever it is. Therefore, we don't have to, we just know x's are liars. So the way that AP Pre-Cal is set up is that it wants you to think of your horizontal shifts as negative, and then you're plugging in a negative instead of thinking of it as minus C and x's are liars, and you know that it replaces it. We're not going to change it from how we thought in Algebra 2 to how we're thinking in AP Pre-Cal because that's just unnecessary transition. All right, next is our vertical translation of the graph. Y equals tan, that's our D, and that simply stays the same. How much are we going up and down? When we're discussing up and down, you're basically just saying, when does the center of your tangent move? So instead of being on the x-axis, is it going to y equals 1? Or, yeah, y equals 1, y equals 2, y equals 3. Where is it going? Okay. All right. Now let's fill in this box. I'm going to be honest with y'all. I don't want to type. So I'm going to resume recording. All right. Here we go. Sorry. So going back to me trying to find it, I couldn't find it. Now, what we're going to talk about is the domain, all those features of this function. And yes, I paused so that I would have not have to write this twice. So when we're talking about the domain of this function, the domain of the vertical of the tangent, it's going to be b times x, okay? Meaning that you're taking your b value, so what your b is, and that times an x. However, it cannot equal pi over 2 plus pi over k. It's just how it's written. That's how your domain is written. And that's because these are the points that are undefined. Okay, your range is going to be from negative infinity to infinity, which is completely different than sine and cosine. Your y-intercept is going to be at 0, 0. Your x-intercept is going to be pi times k. K is just an integer, a multiple. And k is an integer. That's what that k exists in Z. That means it exists in integers. Lastly, you're going to have vertical asymptotes at the odd halves. I forgot to say that k is an integer here, but I can write it. K is an integer. And it has odd symmetry because if you took your paper and you rotated 180 degrees, guess what? It looks the same. It goes through the origin and it has that rotational symmetry. So these are all of our tangent parent function properties. Tangent looks more complicated because it is made up of two functions, and those functions properties have to come together and make one. Make sense? However, if you're reading and analyzing the graph, you can pretty much do all this on your own. All right, so example 1 here. We have this tangent function, and it says that the function f can be written in terms of a tan of b of x plus d, where a, b, and d are constants. Find the values of a, b, and d, okay? So we got to find our a, our b, and our d. By doing so, what's going to be the easiest thing to find? Your easiest thing is going to usually always be your d. Finding that center of the circle, or where it's crossing, where that, what do I call that thing? Critical point. That we're going to look for that critical point. That's going to be our easiest. So I'm going to give you a moment to have you productively struggle to see if you can identify your A, your B, and D on your own as a group. And then we're going to come back together and see what you guys came up with. Okay. And go. All right. I love that y'all are trying. So we're going to go ahead and keep going. You're overthinking it. No, I'm playing. It's harder than what it is. Just want to see what y'all do on your own. All right, here we go. So our period. Period is simple. So first, you need your period in order to find your B, right? And in order to find our B, we need our period. Our period is from one asymptote to the other. So I have asymptote 1 here, asymptote here. It does not matter which one you use. You just got to label them and do the math. So it's always going to be asymptote 2 minus asymptote 1. And that's going to give you your period. Okay? So I labeled, what did I label? Negative pi over 4. I don't know why I chose that, but we're going to go with it. Negative pi over 4 minus negative 3 pi over 4. A negative times a negative becomes a positive. What is negative 1 plus 3? 2. So we have 2 pi over 4, which becomes what? Pi over 2. Okay, so we know that our period equals pi over 2. From our period, the next thing we're going to do is find our B. So we found our period. Now we're going to find our B. Okay, that's because our B is tied to our period. For a tangent function, your period equals pi divided by 2, right? That's what it normally, our period equals pi divided by 2. For tangent, that means that this equals pi over our B. So what does B have to be in order for these to be a true statement? If you can't just say, oh, in order for these to look alike, B has to be 2. Oh, that's ugly. Let's try her again. So therefore, our B equals 2. If you couldn't just see it, remember it's just cross multiplication because this is a proportion. So I would cross multiply. That would give me B times pi equals cross multiply. 2 times pi. Pi's cancel out. So B equals 2. So if it's something you can't easily see, always resort back to the math and let the math be your friend. Okay? Questions on finding the period and the B. Okay, the third thing that we're going to look at is our vertical shift. So 3, we're going to look for our D. When you're looking for your D, you're looking to see, did your center of your tangent move? Did the center of our tangent move? No. That's all D is. Did the center move? Did our center move? Nope. So your D, you're looking for the center. And where the center is located, well, our center is still located at y equals 0. So therefore, D equals 0. How do we feel about finding the D? Good? Okay. Last is going to be finding your A. Your A is where you have to do a little bit math. So to find our vertical dilation, the A, you're going to plug in everything you know and solve. Man, I think I need to change the tip on my pen. She may be a little angry and a little. Okay, so to find the A, we plug in everything that we know and solve. So what we know so far is we know that our B equals 2 and our D equals 0. So we're going to plug in our B and we're going to plug in our D and we solve for A. Does that make sense? Okay. In order to plug in, you have to choose some points on this graph. Doesn't matter what point you choose, but you're going to have to choose an X and a Y. I'm going to always look for one that is a solid point. So when Y is a solid value, you see a point on here where Y is pretty solid. I see it. I'm going to say here at 1. Does anyone know it's halfway between 0 and pi over 4? Pi over 8. I'm going to choose pi over 8 is 1. So we're using on our graph pi over 8, and the output is 1. And that's what we're going to plug in for X and Y. Okay, I'm going to need to add a page because I'm running out of space. Batman. Duplicate. Give me some space. So y'all are ready to plug everything in. Let's list out what we're plugging in. For our Y, so our f of x, we're going to have f of x equal 1. For our B equals what? 2. For our x, we're letting x equal pi over 8. And then our D is 0. We now have plugged in everything except for A, which is what we're solving for. Okay, so I'm going to go to the next page because I ran out of room. You should sub some space, I think, somewhere. I don't know. If not, you be smart. You know what? I can do it at the top. No need to. So plugging her all in, we have 1 equals, we do not know our A, tan of our B, which is 2, our X, which is pi over 8, plus 0. Was it necessary to do the plus 0? No, but I wanted you to see that I plugged in for every single variable. And now our job is to get A by itself, but we need to simplify this first. What is 2 times pi over 8? Pi over 4. And what is the tangent of pi over 4? So we have 1 equals A. I will find the little thingy to take the little tip out and switch it later. Let me make it. Tan of pi over 4. What is the tan of pi over 4? 1, right? Tan of pi over 4 is 1. If we look at our unit circle, when we go to pi over 4, that is square root of 2 over 2, comma, square root of 2 over 2. And your y divided by your x is going to be 1. So the tan of pi over 4 is 1. So we have 1 equals A times 1. So therefore, A is simply what? 1. Is A going to always be 1? No, it may not be that pretty. We may be at pi over 3, and it's not going to be that pretty, right? But do I have everything now to write the tangent function? Yes. So our function is f of x equals, I'm going to write the 1 so that you just know that's where A came from, tan of, and our B is 2x. and this is the tangent function that models. Okay, so when we're writing a tangent function from the graph, these are the 4 steps that we're going to follow. The step 1 is to find our period. And how do we find our period? Asymptotes. Exactly. You're going to choose 2 asymptotes, right? And it's going to be your A2 minus your A1. That gives you your period. After you find your period, you now can find your B. To find your B, you're going to take your period and set it equal to the rule of pi over B. You cross multiply and solve for B, and you get your B. Yes? Okay. Next is 3 is your D. You're looking for the center of your graph. Where's the center of your graph? The center of your graph is going to tell you your D. The center of my graph is right here at 0. So therefore, y equals 0. So therefore, D equals 0. Easy. Okay. Step 4 is where we got to find our A, and we plug and solve. In order to plug and solve, we have to find an X and Y to use along with our B and our D. We plug them in and we solve, we find our A, and lastly, we have our equation. Okay, these are the steps that you would follow for the tangent. Questions, comments about finding the tangent. Okay, were y'all on this track when I was giving you the moment to productively struggle? Kind of. There we go. Okay. Huh? Okay, but there are 4 steps. It's only, I listed in steps because I feel like in step form, it's a little easier to take in. And if you're stuck, you can tell me on what step you're confused. Okay, this is what I learned from last year to do. Yeah. Why? That was the easy one because your A was 1 and your D was 0. Oh, you're saying without that? I see. I see where you're going. Okay. Fine. All right. This one we're going to be going backwards. It says the function h is defined by h of x equals 4 tan 2x plus 5. What is the period of h? Okay, so it's asking me what is the period of h. And I can simply figure that out. Why can I figure that out? Because we have our b. Okay, so we're going to first, we identify our b, and our b equals what? 2. Do we see her? Okay, once you know your b, you're plugging it in the rule. Period equals pi divided by your b. We know our b, so therefore, our period is pi divided by 2. Okay, these are the type of questions that could potentially be on your non-calculator part of the test. It is basically based off of you just remembering the rule for period, the definition of period of tangent. Okay, the math to it is not hard. It's just do you know what you're doing? Make sense? All right. So here's an example of a possible non-calculator multiple choice question. Okay, so when we look up here, it says let g be the function defined by g of x equals 2 tan x over 3 minus 1. Which of the following gives the vertical asymptotes to the graph of g? So this is where it gets a little interesting, right? How could I possibly figure that out without graphing? Because this would be on the non-calculator part. All right. How we figure that out is by determining our period. Okay. So when we look at our, can I go back to the tangent graph for a minute? Oh no. I'm going to go back to our tangent graphs, the parent function. When we're at our tangent graph, notice that there is a pattern that takes place. Our normal period is pi over 2. And how it works is that we start off at, we're at negative pi over 2. That's our first asymptote. Then our next asymptote, then our next point is our halfway point, which is our 0. And then our next asymptote is at pi over 2. That is if our period is a full period. Okay, so when we're analyzing, we would be analyzing it centered around that. And that's where we're looking at how did this change. So how did our parent function change is what we're looking at. Well, in this case, we're focused on the fact that our period started from negative pi over 2 to pi over 2. That's the whole pi over 2. Halfway between is going to be your 0. So you're going to figure out here, we're going to look First thing we're going to do is figure out the period of that question. So we're going to find our period first. And I love that George was like, I really wish that you gave us one that wasn't. Well, guess what, George? There is one that's not just simply. Okay, here's one where your B equals what? What does your B equal? If I'm divided by 3, that means my B equals 1/3. So in order to find your period here, so your period for this one equals, again, it's going to be pi divided by your B. And our B is 1/3. So this leads to pi divided by 1/3. What is pi divided by 1/3? This equals 3 pi. So now instead of every pi over 2, we're now looking at every what over 2? 3 pi over 2. Because our period is now 3 pi long. Does that make sense? Yes? Do we see how that changed? Okay. And again, you just have to remember the rule for the period. And the rule for the period is per tangent, pi over 2. Okay. So once we have that, we then are going to look and say, okay, which one has my period being divided now? By 2. And that answer is C. Uh-oh. So again, these questions aren't going to be hard math-wise. It's all about definition and knowing how to use the definitions correctly. Okay? Our period and our B are related. And in this case, because our period is defined by our asymptotes, our period and our asymptotes are related. Yes? Does that make sense? Okay. Was that terrible? Okay. Tell me if it is. Tell me, like, lady, where'd you getting from? Another possible version of a multiple choice. Remember, all of these would be multiple choice type questions for tangent. Okay, it says, a portion of the function k is shown above. Which of the following could be the expression of for k? So this is function k, and it wants you to choose which one of these is its model. So I'm going to give you a moment for you to decide, check out your table, and then we're going to come back and see how did you guys do on writing the function. Okay, remember our 4 steps and go through those 4 steps. All right, ready, friends? So our step 1 is to look for our period. And our period comes from us choosing an asymptote and an asymptote. Does it matter which one you choose? No, just choose them. So if I went from pi minus negative pi, this equals 2 pi. So we know our period is 2 pi long. Agreed? From our period, therefore, we can find our B, right? So we know that we have pi over B has to equal what? 2 pi over 1. Good job. And 2 pi over 1, this is going to lead us to, we cross multiply. We get pi equals 2 pi B. What cancels out? Pi, so we're left with 1 equals 2b. So our b has to be what? 1 over 2. So our b has to be at half. So that automatically eliminates C and D. Easy enough? On 3, we're now looking for our D. Your D is the center of your graph. Where is that center? Where does that change take place? That change takes place at -2. So we know that D has to equal -2. So what does that eliminate? B. So the answer should have been A. Can you do it? I knew you could all along. I was never worried. I wasn't. I felt like once y'all learned the 4 steps, it would make it easy. Because we didn't even have to do the last step. All right, so what you're going to do here is that this is you practicing finding your tangent. Because you will need to be able to do it without a calculator, you need to make sure that you're comfortable finding the tangent of the values around your unit circle. Okay. Remember I told you all that one of the first things I want you to do once the test starts is to do your unit circle, right? That's the first thing you're going to do on your scratch paper is write down your unit circle. All right. So right now, practicing using your unit circle, you're going to go through and calculate the tangent of pi over 6, tangent of pi over 4, and then check with the neighbor. That is all that I have for you today. The remaining of class is a work day. So that means you should be working on either finishing your 3B.7 practice or starting your 3B.8. Capiche? Questions, comments, or concerns about what we're doing? We're rolling. All right. Go be great.